Thank you for coming to visit our virtual booth at CommunicAsia 2020. Today we're going to talk about why IoT projects fail. But before we start the presentation, I'd like to give a little bit of an introduction about myself and also about Speedcast. So my name is Martin Killian. I'm the IoT Solutions Architect at Speedcast. I've been working in the satellite communications industry for about 16 years. My first 6 years were at Visata, which is now part of Marlink. The last 10 years were starting at Globecom, which is now part of Speedcast. I've been working in sales as well as product management and product development over my career. Now a little bit about Speedcast. Speedcast is one of the largest independent providers of remote connectivity services. We are independent of the satellite operators, and so we have a broad portfolio of services and solutions. We've been designing and deploying and selling IoT solutions since about 2015, and today we have about 20,000 IoT devices in deployment and operation. So, an overview of what we're going to talk about today. First of all, we're going to look at some metrics of predictions on IoT growth rates and where they stand today, how those predictions are coming out. Second, we're going to share our experience of why many IoT projects and ideas never come to fruition. And then last, we're going to provide some of our recommendations for avoiding those pitfalls. So as we look at some of the historical predictions of how many IoT devices there will be, this is a great year to discuss it because 2020 has been a reference year for everybody to make predictions over the last decade. So starting back in 2011, Cisco predicted there would be about 50 billion devices deployed this year, and we can see the next couple of predictions kept getting lower and lower. 30 billion in 2015, 20 billion in 17, and now it looks like we're going to have somewhere between 20 to 26 billion devices actually deployed this year. Of course, this was based on earlier this year. Not sure how the pandemic may be playing out for the actual numbers here. So why are we coming up short of what the predictions are? That's something we're going to discuss and review. And we do know satellite is just a subset of these total numbers, but looking at all the satellite companies who are targeting IoT, it's important that we consider how we in the satellite industry can avoid those letdowns. So we know there are service providers, system integrators, satellite operators, device manufacturers, all targeting the IoT market. We need to know which projects have the highest risk of failure so that we can allocate resources to the projects with the highest probability of success. So we can see just a couple of years ago, Cisco put out another report saying a high percentage of IoT projects were failing. So this is, kind of explains why those predicted numbers are not coming to fruition. So we're going to break this down into kind of three areas of what kind of barriers are getting in the way that and often lead to failure of IoT projects. So the first one we're really going to slice up and look at a few different areas of regulatory barriers. The next one are costs of connectivity. Of course, when you're dealing with satellite, the cost of connectivity is greater than when you're dealing with terrestrial-based and cellular-based connectivity options. So those costs can be magnified even more when you're using satellite. And then the third thing, to be successful at managing data, a provider has to become good at more than just the connectivity layer. So we're going to talk about managing that data end to end, and what are all the components that are involved that you have to be good at in order to successfully deploy IoT projects. Okay, so as we discuss the regulatory barriers, we are going to divide this into 3 categories. So the first one is going to be network and RF licensing issues. The next one is going to be device certification issues. And the third one is going to be data management and data privacy laws. So starting with network and radio frequency authorization, this category varies widely between countries. Some concepts are applicable to both satellite networks as well as cellular networks. As an example, similar to what you see in this article where blocks of spectrum were sold to satellite operators, we were recently looking into private LTE services. In one country, in order to be authorized as a network provider, we were looking at an 8-figure price tag just for access to the frequency block. So typically we will see 2 layers of authorization. First, the satellite or communications operator will need a license or authorization to provide services in the frequency that they are seeking. And then next, many countries will require a local entity to hold a license to sell and provide the service. So sometimes the satellite operator will have an office in country, and then in that case they'll be the direct sales arm and fulfill both of those requirements. But in many cases the operator will set up in-country channels who will be the ones who are authorized to sell in country. So if your company has no presence and your customer needs to use services in that country, which they typically buy from you, these are the types of issues you'll have to navigate. Okay, so the next one I mentioned were device certifications. Another regulatory area you have to consider with your solution are the physical device certifications. Some countries have less stringent requirements than others, but you can't assume that devices will just fall under the network and RF licensing regulatory requirements. So these regulatory requirements, they do cover everything from user manuals to type approval certificates, and this conformance will impact your ability for the devices to be legally operated and also the ability to be legally imported in country. So make sure you take a look at device certifications. Sometimes they're called homologations for whatever country you're trying to deploy a solution in. Okay, and the third one are data management and data privacy laws. So these can be anything from how you store personal data to, is the data being stored in the cloud, and does that country have cloud regulations for where that cloud data center must be located. So it's really important, especially with sensitivity towards data privacy. We know how GDPR has impacted a lot of companies' business models and practices, and so being aware of those regulations and are you in compliance is going to be critical in order for you to have that correct architecture for your end-to-end data flow. Okay, now we're going to take a closer look at each of these and some of the questions you can ask to make sure you are prepared to face these regulatory barriers. So many IoT projects and ideas start with a new market device, or only a few specific devices will be able to meet the deployment requirements. So here are some questions that should be asked when considering RF authorization in a new country. So if RF is not yet authorized it can be a huge barrier to market entry due to cost. So you really need to, a lot of times the RF frequency authorization will quickly narrow down what devices you're able to use and operate in country. So now we look at network licensing. When compared to RF licensing, which is more technical, related to the specific frequency blocks that are allowed, network licensing tends to relate more to who's approved to offer service in that country, who is allowed to actually sell the services. So a lot of times geopolitical issues could come into play in terms of what satellite companies are given authorization. And then also countries usually want to make sure there is revenue going through local entities, so they want a local company to be the ones selling and generating revenue off of that satellite or cellular network. So we had an example of this. We were selling to a customer who needed to operate in a country in the Middle East. We typically provide this customer with an L-band satellite service, which we will buy directly from the satellite operator and then sell to the customer. But in this country, the operator had to sell services through there were about 3 telecom carriers that were allowed to provide the service. So we had to go through one of those local telecom carriers. So when we engaged with one of them to purchase the service, our cost was about 10 times our normal cost when buying direct from that SAT operator. So this is an example where that really broke the business model and made that type of device and solution off the table, took it off the table for that particular customer. So the next one we look at is device certification requirements. So generally this is incumbent upon the device manufacturers to comply with a country's certification and device homologation requirements. So it's not always a one-time requirement. Generally the certification has to be renewed every few years. So the device manufacturers have to keep up with this certification, and that has to be checked on. Also, it's important to consider what paperwork is needed required to import the devices into that country. So to make sure you're not going to have issues at customs, you need to make sure that you're filing the proper paperwork. So being aware of what these requirements are and certifications are going to be important in planning your project out, knowing the timelines that it's going to take to get things in country, and finding the best partners to help you through this process is going to be important. Okay, so the next area I mentioned were data management laws. So I've got these into kind of 3 areas: data privacy laws, data security laws, and regulations impacting cloud computing. So when we look at this last group of potential regulatory barriers, it really gets into how you manage the data. So data privacy laws, I think it's fascinating how these vary across the world and how that variance is having an impact on the current pandemic that the world is dealing with. So a lot of this has to do with how personal information is stored, how it's managed, who has access to it. So and really, how much are the citizens of different countries willing to give people access to that different data? So we know that in some countries they're able to make tracking apps for who's had coronavirus and where they've been and who they may have come into contact with. Where I'm from in the U.S., there's very little of that going on because people in this country really don't want to share their personal information for that purpose. So data privacy laws really impact when the Internet of Things really kind of becomes the Internet of People. And then the next one, the data security laws, and a lot of this is how you store the data. Is it secure? We've seen breaches with companies like Equifax, where billions of people's personal information has been taken by bad actors. So how secure is that data? There's a lot of laws in different countries around this to, again, protect a lot of personal information. And then this can also impact who has access to machines and things that are automated and can be driven remotely, for example. So how secure are those items is very important. And then the last thing here, regulations around cloud computing. So a lot of countries will require that the data is stored and accessed in country. So if you've going into a country that doesn't have a major, one of the big three, Google, AWS, or Microsoft cloud data center, then you might have issues setting up a cloud architecture. So you may have to find ways of how to deal with that, whether it be bringing the data back to an on-premise environment in country, or sometimes the big cloud providers will add data centers when there's a big business case in a certain country. So again, this is something important to consider as you plan your end-to-end IoT deployment. Next major cause of project failure for IoT deployments, and especially when we're dealing with satellite-based deployments, are the costs of connectivity. So many of our customer applications have been working on cellular, but now they have needs where cellular is not available or the cellular is unreliable. So affordable SATCOM solutions are available, but customers have to take a hard look at the data and transmit only what is truly providing value. Sometimes transmission rate of once a minute is being used on cellular, but it could be possible that a transmission rate of once only 15 minutes is acceptable to the application. If you do this, it actually creates already a fraction of the data that's being transmitted over cellular. Another way you can minimize the data is looking at adding intelligence at the edge, which enables smart transmission of data. So you're really only sending back the values that are needed when the values are outside of certain thresholds, for example. When considering the data transmission, it's also important to understand if the solution can use a messaging SCADA type of data format, or if a real-time IP transmission is required. When looking at volumes of data needed, you need to understand, does the asset report kilobytes per month, megabytes per month, or gigabytes per month? And then whether you're on a global roaming cellular plan or a satellite connection, chances are that your subscription includes a monthly bundle of data. Bundle overages can lead to your connectivity costs driving your budget, going over budget for the project. So ensuring cost management tools are available is also going to be prudent when selecting your service provider or designing your solutions if you are a service provider. IoT projects usually have a proof of concept. Every project I've been involved with always starts with a proof of concept. So when you do these proof of concepts, they should not only be for technical validation, but they should also be for economical and cost validation. So customers and stakeholders need to use these proof of concepts also as proof of cost. And then finally, be prepared to make adjustments if some of the metrics end up exceeding original estimates. It's important to consider new technologies when they come available, because an emerging technology could also become available that changes the economics of your application and solution. Now for the last cause of IoT project failures, this is the part I enjoy discussing the most. Personally, I feel the IoT acronym is a bit overused, so let's stop and think about what we're really talking about when we categorize a project as IoT. What IoT really means is that we are taking physical attributes from the world around us and we're making them digital, effectively in a structure that can be fed into a database. But the complexity of initially obtaining this data to getting it into an analytics tool or system which provides value from the data can pose challenges from implementation to lifecycle support of the project. Last year, Microsoft conducted a survey where 47% of respondents believed there's a lack of skilled workers needed to build or maintain a network of connected devices. And we can see in this diagram the breadth of skills required to achieve the end-to-end flow of targeted data values. First of all, you need device experts, people who understand the devices which are able to operate in the target environment, devices which support the power requirements to obtain and transmit data, which meet regulatory requirements that we reviewed earlier, and which are cost-effective in all aspects of implementation. Device selection and network connectivity go hand in hand, and therefore cross-collaboration amongst teams is critical. But once you're able to identify these components, you will then need data science and often software experts. The project may require data manipulation at the edge, which again brings in device considerations. If there is a human operator at the edge, you may even need a visualization tool at the site. We often see this requirement in the energy sector, where on-site engineers need real-time views of wellhead operations. Traditionally, the middle part of this diagram is where the satellite and telco providers have excelled. But when it comes to IoT, we now must incorporate the left and the right sides to ensure that we are properly securing the data and reliably delivering it within the parameters defined by the application. Is the data going to a cloud data center versus a customer on-premise data center versus a traditional data center? What's the point of demarcation for data handoff? Who owns the infrastructure, and therefore who takes responsibility for data storage and the security of that data once it reaches the final destination? These are just a few of the questions you must find answers to as you design each customer solution. So we've spent a bit of time talking about what leads to IoT project failures. What about the things you can do to avoid these issues? Let's review a few of the subjects we've touched on. So we spent a bit of time on regulatory barriers, and we did touch on a lot of questions you can ask up front to make sure you're designing a solution that will get regulatory approval. But as a company, you need to think global. At the same time, you've got to act local. By this, I mean you need to have regulatory resources and people who have local knowledge of the countries where you're trying to deploy your IoT projects. Next, when it comes to cost of connectivity and trying to minimize the cost of connectivity, first of all, you want to have a lot of technology options because different technologies may have different economic implications depending on what your exact application is. So having technology options from different vendors and partners is going to be one key to having success. The next key is going to be minimizing the actual data volumes and optimizing the data that goes over your satellite path. And then the third thing you need to do is make sure you have cost control tools in place. If you can avoid any kind of bill shock, then you're going to increase the possibility of success for your IoT deployments. And then finally, managing the end-to-end data flow. Really at a higher level, you can't say yes to every single IoT project and idea that comes across your desk. very few companies have the capability to have full system integrations and deliver full end-to-end solutions. So you've got to have companies and partners who have strong vendor relationships who can do that system integration. And then finally, it's really comes down to the people. We talk a lot about the technology that enables IoT, but a lot of people do forget about, what really makes it all work is the people. Having strong, knowledgeable people and strong partnerships are going to increase your chances of success for your IoT projects. Thank you again for your time today. Here's some information if you have any questions, how you can reach us. There's a portal here with a chat box. I can be reached personally at my email address, and our director of our IoT business unit, John Gisa, can also be reached. We look forward to interfacing with you and exploring some of the projects you might have in mind.